Hello everyone. So my name is Saurabh Pant. I teach chemistry in Sri Chaitanya Goshala campus, and by this time we know each other from last 4 lectures. This is the 5th one. By this time we have started the nitrogen oxygen family, the most beautiful part in the inorganic chemistry, that is the blocks we are dealing. Other students are frightened with the blocks, but we are the expert in the block. So one by one we are going to deal all the remaining topics also. So in the last lecture, this part I left for you, and it is left as it is, so we will be touching this part here. But before entering this part, I would like you to just be acquainted with the oxy acid and hydrides. What are these terms? What does they mean? So what is oxy acid? Oxy acid means an acid containing oxygen. Like you can see the examples here, all of these acids, they contain oxygen also, one central atom also, and hydrogen also. Hydrogen to release the H+. So let's carry on. Now here what we have to understand is that this P4O10, P4O6, these are two non-metal oxides. Non-metal oxides are acidic in nature. Why the non-metal oxides are acidic in nature? Because they go in the aqueous medium and they form acids or oxy acids. So देखो यार how to do. So P4O10 forms H3PO4. Sir, how to remember this? Like what is the trick for it or what is the logic for it? Logic is very simple. Until it is extremely necessary, oxides do not undergo disproportionation. That means they will, for example, here the phosphorus is in +5 in P4O10 and H3PO4 also phosphorus is in +5. So +5 oxide of non-metal forms oxy acid in +5. Similarly, +3 will form the oxy acid in +3. So P4O6 +3 forms H3PO3 +3. Similarly, N2O5 nitrogen +5 will form the oxy acid HNO3 which is in +5. N2O3 nitrogen in +3 forms the oxy acid HNO2 nitrogen in +3. CO2 poor fellow is only showing one oxidation state, that is +4 in the oxide which is acidic in nature. Sir, but CO is also there na? Haan, but CO is neutral. So bhaiya, CO is neutral, he will not form any oxy acid because he is neutral in nature. How can he form the acid here? Then what happens? CO2 is in +4, so he forms the oxy acid in +4, that is carbonic acid. SO2 is in +4, sulfur is in +4, so he forms H2SO3 in +4. So here also sulfur is in +4. You can check also by you taking the oxidation state as X, hydrogen as +1, oxygen as -2, you will get the +4 oxidation state. Similarly, sulfur is in +6, forms the oxy acid H2SO4 in +6. So make sure to write this thing today. As soon as the lecture gets over, take a paper and try to write all of them by yourself also, and you will be very, very happy in the remaining chapters. I guarantee you the most useful thing for the inorganic reactions is this chart. If this chart is done now here, all the S block, junior inter S block and boron carbon family reaction with a single snap of finger you will be able to write. But understand this thing, you have to remember it. Now, these are known as ortho acid. What is ortho acid? If non-metal oxide go in water, the acid they make is called ortho acid. Whereas these are called anhydrides of this acid. Anhydride means water ledu, no water. So if I remove water from here, I get these oxides. So they are called anhydride, they have no water left. And when you add water to the anhydrides, the acid you get is called oxy acid and ortho acid, ortho-oxy acids. So these are the oxy acid, these are the anhydride. Now start the tricky part. So let's talk about nitrogen first. So देखो भैया, nitrogen highest oxidation state is +5. Now understand, whenever you make the oxy acid, if the highest oxidation state is +5, just decrease the number by 2 and 2 and see how many positive numbers you can get. So think about it, what I'm trying to say. +5, next number +3, next number +1. Decrease by 2, 2 and see how many positive numbers you can get. So here I have made a chart for you. So it's such a lallu chart it is na yaar. Class 6th, 7th student, even class 3rd, 4th student will be able to tell this thing. So don't complicate it for yourself. Don't see it is looking dirty. I know my handwriting is not very bad, but theek hai, when too many things come together, it looks bad. But see what I'm trying to say. +5, 2 less, +3, 2 less, +1. So only 3 positive numbers I can get. If the highest is +6, oxygen family, then +6, 2 less, +4, 2 less, +2, and the next number is going to be 0. So positive 3 numbers I can get. +4 is the highest, +4, +2 will come. +3 is the highest, +3, +1 will come. If 7 is the highest, then 7 can come, 5 can come, 3 can come, 1 can come. So bhaiya total 4 different oxidation states are possible. So with nitrogen, the highest oxidation state is +5. So what is the meaning here? It means that nitrogen will show +5, +3, +1. So 3 oxy acids are theoretically possible. Which are those 3? HNO3 +5, HNO2 +3, and H2N2O2, that is +1. Before going ahead, how to name them? Very simple. The highest oxidation state, if there are 3 people, always we start from the bottom here. If there are 3 people, then the highest will be named as ic acid, lower Ous acid, lowest hypo-Ous acid. If there are 4 people in the series, like chlorine family, there will be 7 +7 up to there, halogen. So there I will use perchloric, chloric, chlorus, hypochlorus. But here right now it is nitrogen. So nitrogen highest +5. So we will write nitric acid HNO3, nitrous acid HNO2, hyponitrous acid H2N2O2. See the logic here now here. So what happens here? This NO2 goes in water, and what happens? Nitrogen is in +4. So is there any oxy acid of nitrogen in +4? No sir, we know HNO3, we know HNO2, we know H2N2O2. So there is no oxy acid of nitrogen in +4. Then sir, what to do? Simple. If you don't have any oxy acid in that oxidation state where the oxide is present, write one up, write one down. What does it mean? NO2 in water goes to form HNO3, one up, and HNO2, one down. So +5, +3 both will come. So such kind of anhydride, this kind of anhydride is known as mixed anhydride. So NO2 is mixed anhydride. Why? Because it is forming 2 different combinations of oxy acids. Why so? Because +4 oxy acid is not there, so I took one up and one down. Going ahead, N2O, laughing gas, is neutral. Laughing gas is neutral. So understand one very tricky part that happens here. What we have understood is that same oxidation state oxy acid is made. है ना? Sir, then for nitrogen, which is in +1, we should make H2N2O2. No. Very, very wrong. Baga, chadda. Why so? Bhaiya, simple logic yaar. There are 3 gases which are neutral in your course: CO, NO, and N2O. And if N2O, that is laughing gas, is neutral, how can he form the acid in the aqueous medium, yaar? So that's why CO cannot form any oxy acid in the aqueous medium, N2O cannot form any oxy acid in the aqueous medium. That means N2O is not the anhydride of anyone. N2 form no oxy acid in the aqueous medium, so is not anhydride of H2N2O2, is not anhydride of anyone. So bhaiya, this was the basic part up to here. Going ahead. Now, how to name them? Let's see some naming we can do here. For example, I give you 3-4 compounds name, and you will try to name them using this logic here. So for example, we take some 2-3 examples I will take, and you will love those examples if you understand them more logically, more nicely. So let us take the example of H3PO4, H3PO3, and H3PO2. So it is in +5, +3, +1. Any further is not possible, so 3 are there. So the first one will be named as ic acid, that is phosphoric acid. Second one will be phosphorus acid. Second one, Ous acid, because higher oxidation state, ic, lower Ous. When you will disturb this person? When 4 oxy acids will come, then you will disturb this person. Going ahead, H3PO2 will be called as hypophosphorus acid. Why hypophosphorus acid? Because bhaiya, hypo-Ous acid for the lowermost oxidation state. Understand here now, what will happen if I make their anions? That means PO4 3 minus, ic acid is the acid, so the anion will be named as phosphate. Why phosphate anion? Because ic acid 8. Whereas if I take H3PO3, his anion is there HPO3 2 minus, then his name is going to be HPO3 2 minus, the name is going to be phosphite. Why phosphite? Because when we have Ous, the anion is ite. So hypo-Ous, that means hypophosphorus acid, the anion is going to be hypophosphite. Similarly, if I make HPO2, You can write H2PO2 minus. It will be known as hypophosphite ion. So I think this part is clear to us how to name it. Ic acid, whenever the halogen family will come, before that don't worry about ic acid. So for in this topic, highest oxidation state ic, per ic is later on to be used in 17 group. Lower OS and lowermost hypo-OS. Similarly, nitric, nitrous and hyponitrous acid. So anions will be nitrate, nitrite, TE, nitrite and hyponitrite ion. Now, I am going to enter into that part that you were waiting for quite some time now, these structures. So, understand the maximum covalency of nitrogen is 4. That means he can make only 4 covalent bonds maximum. So, the structure of N2O4 is the parent structure I am going to start with. So, this is how N2O4 looks like. 2 N are combined to each other, double bond O, single bond O, double bond O, single bond O. Now, is there any resonance here? Yes, lone pair, single bond, double bond. So, there is a conjugation possible here and there is a conjugation possible here also. So, what happens here? If I ask you ki out of X and Y, which bond length will be larger? So, bhaiya clear cut I will say X will be more than Y. Sir, why so? Because X is a single bond. One logic, X is a single bond. Whereas outside you can see this double bond is getting delocalized due to conjugation. So, it is partial double bond. So, partial double bond is stronger. Stronger means the atoms will come close to each other, so the bond length will be lesser outside. One more logic is there that you can remember for all the chapters. For boron carbon family also, the bond in the middle, you can understand they will get stretched. So the bond in the middle is always larger than the bond in the corners. By default, every structure you will see every time, any structure. So the middle bond is going to be always larger because these molecules will try to go away and they try to stretch. Conjugation is there, resonance is there, yes. Bond angle is 135 degree. Why is it important? You will get to know now. Now, when I talk about the structure, this was N2O4. For N2O5, question is that you can check nitrogen is making 1, 2, 3, 4. This is the coordinate bond also. Coordinate sigma bond, chemically sigma bond and coordinate sigma bonds are same. So, you don't have to worry about the chemical nature there. It behaves exactly as a sigma bond, no difference at all. Just I am asking you, how many bonds nitrogen made here? So, you can say, sir, covalency of nitrogen here, number of covalent bonds of nitrogen here is 4 and the oxidation state is also +4. But in N2O5, bhai sahib, I want to make now one more extra oxygen here. Problem is, nitrogen covalency is 4 only. That means, I have to do something. I have to do something in this way that this nitrogen covalency is not extended. This nitrogen covalency does not get extended. Still one oxygen fits inside. Yeah, you are scientist now. You can tell me where can I fit this oxygen here? Like here 1, 2, 3, 4 bonds are made. So if you are thinking properly, you will understand, sir, can't we put it here in the middle? Like this. Then what will happen? One extra oxygen also came and you can understand covalency of nitrogen is also not extended. Arre bhaiya, brilliant answer. N2O5 structure comes like this. Here there is a bond angle. Here there is a bond angle. So bhaiya, we have to understand here the bond angle is around 134, 135 degree only. So near about same angle is there, here also, there also. In case you ask ki out of X and Y, which bond length is more? So bhaiya, clear cut inside bond length is going to be larger than the outside bond length. Inside bond length is going to be larger than outside. Stretching we can say, single bond character we can say, whatever the reason you want to give, both are equally correct. Going ahead, this angle is comparatively lesser, around 112 degree angle we say. But anyway, the inside angle, outside angle, if we compare, let's say this is theta and let's say this is psi. So always psi will be more than theta here. So this is how the things are going to be here. Going ahead, in N2O3 structure, what to do? Simple yaar. In N2O3, you have to just remove one single bonded oxygen from N2O4. N2O3 will come. Question arises, here do you have any conjugation? Answer is negligible, almost no. Whereas, here the conjugation is still going on. So this Y and X, if I compare, the bond order of Y is 2. Why? Because a perfect double bond. The bond order of X is not 2. Why, sir? Why not 2? because conjugation is going on, this double bond is getting delocalized in this 2 position. So this double bond is getting equally distributed in this 2 position. So one sigma bond and half of pi bond each one are getting. That means the bond order is around 1.5. So who has more bond order? Y. So whose bond length will be lesser? Bhaiya, outside, because double bond will be shorter than partial double bond. Double bond means very strong as compared to partial double bond, so shorter bond N2O3. So what is the covalency of nitrogen in the N2O5 structure yaar? Covalency is 4. Oxidation state bhai sahab, +5. What is the covalency of nitrogen in N2O3? One of the nitrogen having 1, 2, 3, 4. Covalency here 4. And here nitrogen 1, 2, 3. Covalency here 3. So covalencies are different in this case. Covalency both the nitrogen 4, 4. Covalency both the nitrogen 4, 4. And this is the topic of the structure of nitrogen oxides and their comparisons of bond length and bond angle. Let us move on to the next topic. So students, now I'm going to start with the oxy acid part. Here a little bit of quick recap of the chemical bonding we will do. There is a large trick for finding the hybridization and the valence electrons and all those things, but here I will deal some shortcut to find the structures for this group specifically. So let us see, I have to find the structure of H3PO4, which is known as phosphoric acid. How to find? Simple trick is there, listen carefully. Out of all the oxygen, give one oxygen as double bond O. So you have given one oxygen as double bond O. Remaining oxygen combined with the central atom with single bond, single bond, single bond. So out of 4 oxygen, 1 came as double bond O, 2, 3, 4. So brilliant, by this time you have got this thing. What about hydrogen now? Oxygen got arranged, what about hydrogen? Hydrogen is firstly given to, give hydrogen first to oxygen and then if left to central atom. And to which oxygen? To the single bonded oxygen. So how many hydrogens are there here? 3. So we will give 3 hydrogens here. So we understand khatam yaar, there is no hydrogen left, and this is the brilliant structure of H3PO4. So if someone asks you how many acidic hydrogens can you see here, so the answer is 3. Number of acidic hydrogens are also known as basicity. So basicity is for acid, higher. Basicity is for acid, acidity is for base. This you have read in the equivalent chapter or redox chapter. Anyway, so number of acidic hydrogen 3, so the basicity of H3PO4 is 3. Going ahead, is it going to be a reducing agent ever? So bhaiya, this cannot be a reducing agent. Why? The people in the highest oxidation state, they are oxidizing agent, they are not reducing agent. They cannot be further oxidized. So they cannot act like a reducing agent, because reducing agent has to get oxidized. If I am already in my highest, how can I get further oxidized? Na yaar? Going ahead, H3PO3, 1 oxygen has double bond O. How many left? Out of 3, 2 left. So 1, 2 oxygens came like this. Hydrogen 3. So firstly I will give to the single bonded oxygen, then to the next single bonded oxygen, and when hydrogen will be given to the central atom, because there is no oxygen left now. So how many acidic hydrogens are there, or what is the basicity here? So acidic hydrogens are 2. This hydrogen attached to the central atom directly is known as reducing hydrogen. What we call it? Reducing hydrogen, and this person is responsible for the reducing agent nature. That's why there is no reducing hydrogen here. He is not a reducing agent, but here reducing hydrogen is there. Going ahead, this is the structure of H3PO3. Next, understand this H plus can never be deprotonated. He will remain like this only. So the anion can only be HPO3 2 minus maximum to maximum. In H3PO2 yaar, double bond O. How many oxygen left? 1. Give as a single bond O. How many hydrogen? 3. Firstly give to oxygen and then give it to the central atom. So how many reducing hydrogens we can see here yaar? So the reducing hydrogens are 2 and acidic hydrogen is 1. So bhaiya, basicity is 1 but reducing hydrogens are 2. So if I ask you out of H3PO3 and H3PO2 who is the better reducing agent, so sir 100% H3PO2 is better. Why? Sir, there are 2 reducing hydrogen, why not? One reaction you can see, AgNO3 get reduced, Ag from +1 get reduced to Ag in the presence of H3PO2. So H3PO2 act like a reducing agent. He reduces Ag plus 1 to Ag. Sir, what happens to him? Nothing. He get oxidized to H3PO4, the higher oxy acid. He get oxidized. That is the secondary part. Ag plus 1 get reduced to Ag. One more reaction. Wait till the end of your course. You will read in the diazonium chloride also. There as well, in the nitrogen, in the organic chemistry, nitrogen containing compounds, there also this H3PO2 uncle will come and they will also reduce your diazonium chloride to make benzene. Chaliye, going ahead. Next part, if your structures are clear here, next part is that ortho acid. Ortho acid we have read in the previous part. Ortho acid minus water is meta acid. Ortho minus water is meta. To understand, for example, ortho acid H3PO4 I have taken. I subtract water from there, simple A minus B we are doing. So 3 minus 2 hydrogen, 1 left. Phosphorus came as it is. 4 minus 1 oxygen, 3 came. So HPO3, this thing will be known as metaphosphoric acid. Sir, why metaphosphoric acid? Because from orthophosphoric acid, you subtracted water, you get meta. So that meta acid is called metaphosphoric acid. The structure of metaphosphoric acid looks like this, and this is not stable. So we exist like a polymer or as a cyclic trimer. You can see the structure. So P double bond O OH, and this dative bond oxygen gave the electron to the next phosphorus. Double bond O OH, his oxygen gave the electron to the next phosphorus, and a polymeric chain is made. Polymetaphosphoric acid. How do we get the cyclic structure? This is more important. P double bond O OH as it is, and the O here, single bond dative bond O, give the electron to the next phosphorus, OH double bond O. His oxygen gave the electron to the next phosphorus, double bond O OH, and this oxygen gave the electron to the first phosphorus, and instead of getting a polymer, it became a cyclic trimer, and it is known as trimetaphosphoric acid, H3P3O9. If I remove all the H plus from here, we can see the acidity is 3 here, sorry, basicity is 3 here, acidic hydrogens are 3 here. If I release all 3 of them, P3O9 3 minus will be formed, and ic acid anions are named as 8. So bhaiya trimetaphosphoric acid will be named as trimetaphosphate anion here. Now, which kind of pi bond is this? So understand, phosphorus uncle is sp3 hybridized. I have discussed this in the second and third lecture. Third lecture I have discussed. Phosphorus is sp3 hybridized. So we understand no p orbital left for pi bonding. So phosphorus uncle has to give d orbital for the pi bonding. Oxygen is second period element. He has no other orbital to give. So he will give p orbital for pi bonding. So phosphorus was sp3 hybridized because you can see 1, 2, 3, 4 sigma bonds he is making. So sp3 hybridized, p orbitals, I point the, what happens? He have to give the d orbital for the pi bonding. So p pi d pi. So how many p pi d pi bonds here? 3 p pi d pi bonds in total you can see here. Going ahead, how to write the structure of polyatomic acids, polycentral atom acids. Polycentral atom means like here there are 2 phosphorus. So dekho yaar, this the structure is later on, the name is hypophosphoric acid. Now how to write the structure? If you ever get H4P2O6, H4P2O7, something like that, if you ever have odd number of oxygen atom, now odd number, put that oxygen in the middle. If not, distribute equally. Rule is the same as the previous one. So here we have even number. So I will write P single bond P and give equal on both the sides. So number 1, give double bond O to both of them. Then out of 6 double bond O, 2 given, how many left? 4. So 2 oxygen nikada, 2 oxygen nakada. Then what? Attach hydrogen to the oxygen, single bonded oxygen. 4 hydrogens. So 1, 2, 3, 4. So how many acidic hydrogen? 4. So bhaiya, it is tetra basic acid. Basicity 4. Tetra basic acid. That means he will react with 4 OH minus by releasing the H plus. Going ahead. So dekho yaar. Ortho plus ortho minus water is known as pyro acid. Ortho minus water, meta acid. Bhaiya, meta para nahi, meta pyro. Inorganic chemistry is going on. Don't mix and make a khichdi. So understand, ortho plus ortho minus water is called pyro acid. So H3PO4 plus H3PO4 minus water, phosphoric acid plus phosphoric acid minus water will give me pyrophosphoric acid. To understand how to make this, H3 3, 6 minus 2, 4. 4 plus 4, 8 oxygen minus 1, 7. And P2 as it is. So the structure is H4P2O7. Let's draw the structure. Trick is simple here. If you have odd oxygen atom right in the middle, chamka bhaiya, out of 7, how many left now? 6. give equally. So first thing, double bond O, double bond O. How many left now? Out of 6, 2 more consumed, 4 left. So vakati, rendu, moodu, nalgu. Then what to do now? How many hydrogens? 4 hydrogen. Give to the single bonded oxygen first. So 1, 2, 3, 4. So this is your structure of pyrophosphoric acid. And here you can see bhaiya H3PO3 plus H3PO3 minus water will be called as pyrophosphorus acid. And this is your homework to draw the structure of H4P2O5 bhaiya. Trick is very simple. Odd oxygen in the middle. On the phosphorus, firstly give double bond O. Then remaining oxygen given as single bond O to the phosphorus. Attach hydrogen to single bond oxygen. And if left, here you will get something left. Attach to the central atom. Now, the last thing here. Very, very important reaction, that H3PO3, which is in plus 3, on heating becomes H3PO4 plus PH3. And bhaiya H3PO4 is plus 5, PH3 is minus 3. So we understand H3PO3 is getting disproportionated. It was there in the beginning part also. If you read the NCERT, I did not touch that point here because it did not make any sense there. But now it can make sense that intermediate oxidation state of phosphorus can get disproportionate to the highest and the lowest oxidation state. So for the phosphorus, the lowest oxidation state minus 3, highest plus 5. Now, this reaction is very, very important. H3PO3 get disproportionated on heating. One more small trick you can remember. For P block element, oxidation states are going to be valence electron 2, 8 minus valence electron, or valence electron minus 8, sorry. Valence electron minus 8. For nitrogen family, valence electrons are 5. So 5 to 5 minus 8, minus 3. So bhaiya 5 to minus 3 are the range of oxidation states here. That's why plus 5 highest, minus 3 lowest. Do it for oxygen family also. Brilliantly you will understand. Valence electron 6. What will happen? 6 minus 8, 6 to minus 2. So bhaiya for sulfur the highest oxidation state plus 6 and the lowest is minus 2. So bhaiya this is what we have covered by this time. All the nitrogen oxides already covered, structure covered, oxy acids covered. And now in the next lecture, we'll be slowly crawling towards the ending of nitrogen family and the beginning of the compounds of the oxygen family. So this was all. I hope you all are safe at home. Stay safe, read very well, stay at your home, and together we can make a big difference. Thank you so much.